Hello, everyone. Welcome to the Advanced Manufacturing Technologies for Welded Structures course. Today, we will study the second part of basic knowledge of assembly positioning. I'm your lecturer, Xiao Yong. In the previous session, we studied some foundational knowledge about assembly positioning. Now, let's delve deeper into the commonly used locators and their applications, considerations when using them, and various assembly positioning methods. Let's first look at common locators and their applications. Locators can be classified based on their geometric structure into plane locators, hole locators, and cylindrical surface locators. When positioning on a plane, stops are used to hold the workpiece on a horizontal or vertical surface. They are simple and commonly applied. Support pins are also frequently used. Their structure and dimensions are standardized and include fixed, adjustable, and support plate types. Support plate locators can be either smooth or slotted, suitable for vertically or horizontally oriented machining surfaces, and provide stable support for large workpieces. When locating via holes in the workpiece, locating pins are essential. These come in both fixed and interchangeable types. For cylindrical parts such as pipes or shafts, V-blocks are frequently used. Fixed single V-blocks suit short workpieces, while long or intermittently shaped cylindrical shafts require double V-blocks. There are many considerations when using locators. Generally, they should not serve as load-bearing components, as doing so may affect positioning accuracy. If they must bear loads, their strength and rigidity must be enhanced. Locator placement must not hinder operator tasks and must allow for easy removal after welding or assembly. The working surfaces of locators must be wear-resistant to maintain long-term accuracy, and if worn or damaged, they should be easy to repair or replace. When choosing a locating reference, machine surfaces or holes that meet requirements can be used, and locators are typically not used alone. In practice, they must be paired with clamping devices to prevent movement during assembly or welding. Additionally, when placing welding locators, they should be close to the machined surface of the weldment. For structural steel pieces like angle or channel steel, the locator should be placed on the back or edge, not on the sloped inner surface. The layout must not interfere with cutting or welding operations and should prevent deformation of the weldment. Otherwise, the assembly may become immovable after welding. The locator itself must also have wear resistance and structural stiffness to ensure reliable and stable positioning. Next, let's move on to assembly positioning methods. Tack welding, also called spot welding, is used to secure the relative positions of already positioned parts and ensure the correct shape and dimensions of the structure. During operation, the correct diameter of electrode or welding wire should be chosen to ensure weld penetration. If defects are found, they should be removed and re-welded. The arc start and end should have smooth transitions. The length of tack welds is related to the plate thickness. Thinner plates require shorter welds, thicker plates need longer welds, and the spacing is determined by practical conditions. Scribing on the surface of the workpiece or assembly platform, such as center lines and joint lines, helps to determine the correct position of components before fixing them with tack welds. A support seat, consisting of a base plate, channel steel, side plates, and stiffeners, can then be used to assemble the structure following the scribed lines. The length and spacing of tack welds are generally determined by the thickness of the plate. For thin plates, smaller values are used. For thick plates, larger values are used to ensure welding quality. The template positioning method uses a template to determine the position and angle of the part. After clamping, tack welding is performed. This method is suitable for assembling steel plates at specific angles and installing pipe nozzles on containers. For example, Slanted T-shaped pipe joints can be precisely positioned using prefabricated matching templates. The stop block positioning method uses specific locating elements to determine part positions. Components are clamped and assembled without the need for scribing. This method is efficient and provides high-quality results, making it suitable for batch production. For example, during single or small batch production of I-beam components, straightening and scribing are performed first, followed by welding stop blocks to ensure verticality and correct positioning. The fixture-based positioning method, such as the assembly of a double-arm angular lever, involves determining positions using pins and locating dowels, adjusting height with shims, and completing the assembly with clamping and tack welding. When positioning is entirely handled by fixtures, the assembly quality is reliable and production efficiency is high. For batch assembly of I-beams, simple fixtures can be used in combination with stop blocks and shims to determine position, secured by screw clamps and verified with a square, efficient and accurate. Finally, let's talk about fixed and mobile assembly. Fixed assembly means all the assembly tasks for a product or component take place at one stationary location. This approach is suitable for large welded structures or single or small batch production, such as the on-site installation of large spherical tanks. Installation process of spherical tank. The structure of a spherical tank includes the equator band, upper and lower temperate zones, upper and lower domes, and support legs. The installation sequences: legs, equator, lower temperate zone, upper temperate zone, dome. Mobile assembly, also known as flow line assembly, involves moving the product or component along process stages. It offers high efficiency, good quality, and low cost, making it ideal for mass production. For example, the main beams of bridge cranes are assembled using a flow line setup. In mobile assembly, products are moved using conveyors or similar tools, and specialized equipment is often employed to meet the requirements of different process stages. The content covered today is highly relevant to practical manufacturing. Please review it carefully after class and feel free to ask questions. I hope everyone gains a solid understanding of these concepts and builds a strong foundation for future learning and work. This lesson is concluded. Thank you for listening. Goodbye.